Hey everyone, Sebastian here, and welcome to episode 12 of Learning Game Development. Let's just hop right into it. And these errors are still here. I will never know what they mean, but that's fine. Alright, today I'm gonna try and make all the progress, really. I'm gonna try and finish it out here, actually, today. I really do believe I can. Um, Yeah, I'm just gonna make the enemies and then. Sorry. I'm just going to make a bunch of enemies, create their paths, and then. Um, Actually, I guess that's it. Make a bunch of enemies, create their paths, and then not do anything else on my own. I'll probably just follow the tutorial for the rest because what I've done by myself without guidance is already kind of a lot. So I will be satisfied with doing that amount on my own. All right, so I actually want to set this to, yeah, that doesn't work. I'm wondering, so what I want to do is I want to set the parent of the path points to the plane here. That's the first thing I want to do. Oh wait, I can just do this, bro. Type find object of type, I think. Yeah. And then I could just do transform. Sorry. Plane. Oh, sorry. Level. Huh. Would that work actually? Wait. Huh. Wait. Oh. Hmm. Level plane. How do I actually what? Transform dot level plane. Okay, now I'm gonna have to look this up. How to set the gamer. How to set the parent of an object, sorry, of a game object. Game object to a specific object. Sure. Um, Oh, do I actually have to? Okay. Okay. Yeah, I think I may actually have to just do that. That may just be the easiest thing. How do I do, what is it? Find object of type? Of type? Nice. Wow. Bool? Type? What? Text mesh. That's not, that's not, that's not what I want. Uh, hmm. Find an object of type will not return assets. Meshes, textures, prefabs, or inactive objects. What? Sure. Alright, if we do game object dot, huh, what does this do? Alright, maybe there's like this kind of thing, maybe? Level plane? Mm. I actually forgot how to do this. Aha. Wait, if I do player controller dot, what is it? Oh, I didn't put any methods here. Delay? Can I do delay? No. What? Texture is not a bool in this circumstance. What? In the world? Whatever. It is not a boolean in this circumstance. First object of type as a direct replacement. Okay. That, what? This is not it. This is not it. That's not it. This is not the one he used. That is not the one he used.
Hi everyone.
Is it here?
So that's the one that will be loaded. All of this would be to simply make the method public and then head over to the now
What? Game over. Dot on game over. Okay, so that's a script. Maybe I can't. I guess I maybe can't do it this way. That's fine. That's fine. How to set a parent. How can I make a 3D object follow the player in C sharp? Yeah, I'm actually thinking it's just gonna be easier to. Oh. Oh, that's easy. Nice. Yeah, that's easy. That's easy, Brody. That's so easy. What? Oh, I have to do this, really? Okay, do I have to do that? What? Transform dot. Okay, how?
Hello. Hi everyone.
Yes, yes, that was correct.
Hi everyone. Today we're going to be finishing off this mini project by adding in a game over screen. Before we get to that though, let's just make that these falling blocks screen height in world units is simply the height threshold. So that visible height.
Wait, he just showed me. Um, there should be a way I can just fudging put it here. Like, wh why can't I just put it here? Find object of type. Oh, wait, I can actually do this? Can I actually just do this? Type. I have to specify the type. Okay, and then this I have to do. Uh, no. dot find, and then can I just do this? Can I please do this? What the fuck? Oh, maybe I could just actually. Oh, maybe I could just do that. Okay, I see. I see. I see. That should work, right? Probably. And then open that, and then play. Uh-huh, I didn't. Ah, and then it should. Boom, there, easy. Wow, that was so easy. It definitely didn't take me almost 17 minutes. Okay, so now I have to change this to, um, how do I get it to face? How do I get it to face this? Vector 3 dot move towards. Maybe there is a vector 3 dot face? Vector 3 dot angle between. Calculates the angle between vectors from and. From and. That's not a grammatically correct sentence, but that's fine. Um, Distance dot equals exclude forward. Uh, Rotate towards. Rotates a vector current. Oh, wait a second. Is that actually... Is that actually it? Wait, what? Yes. Bro? This is a quaternion, I'm guessing? Oh. Oops. So I have to do this. I have to do the same thing. What? No, there has to be an easier way to do that. Do I have to make this a quaternion? Slurp. Huh. Yeah. Max magnitude delta? What? You know what? That's fine. Let's see what happens. And these are overloads, or do I have to do all of them? I do. I. Maximum angle in radians allowed for this rotation. 180? Radians? Okay. Sure. The maximum allowed change in vector magnitude. What? The maximum allowed change in vector magnitude. 1, I guess? Alright. Now, I'm just gonna rotate this around. What the fudgeroni? What are you fudging doing? That is not correct. Okay. I want to rotate this. Just this. What are you yeah, what? What are you doing? What? I want to rotate the phi, please. What is happening? Okay. Guess I'm gonna remove it. Oh, no, I'm gonna do this one. Okay, thank you. What the fudge? Alright, now let's try it. Fudge? Oh, this is also going to, yeah, I'm gonna make that an I enumerator later. Why do I keep playing this? Why do I keep playing this? I don't need to do that. Thank you. Okay, maybe I don't even need this? Wait, what? You know, maybe this is good. Here. No, it's not. No, it is not. I'm trolling. I'm trolling. Okay, now? What? The fu- I want it to... What? Hmm. How do I make... Why do I need vector 3 current? Why do I need that? Why do I need that? In degrees relative to the parent transform's rotation. In degrees relative to the parent transform's rotation. I keep forgetting. I keep forgetting. Okay. That did not work. That did not work. World position. What? This should work, right? Transform dot transform target. Transform target. Transform. Transform. Okay. Uh, okay. Please. Please? What the fuck? This is causing me so much pain. This is causing me so much pain. You know that should be over there. Now I'm going to put that down there. Great. Now I'm going to play it. Oh, yes, baby. Oh, yeah. Oh, yeah. Oh, yeah. Okay. I did it. Okay. I did it. I did it. He did it? He did it. He did it. Okay. Okay. Yep. Perfect. Um, Now I just have to make an enumerator called, uh, sure, follow path. Why not? And then in this, it's going to take, oh, it is not. It's not gonna take anything actually. Uh, yeah, nice. In this, yeah, I'm going to do for each, um, Yeah. Okay. I'm just gonna freaking copy this. Really? And then I'm going to remove this. Then I'm going to do enemy move. And then, I don't know, 5, I guess. Oh, public float. Why didn't that work before? Whatever. Okay, public float speed. I don't need that. And then I can just boom. And then I can do, do I have to do another loop? Really? Uh, sure, I guess I'll just do a wait. That's fine. 2 seems good enough, I guess. So that's 5. That's 5 as well for some reason. Okay. I didn't. Yay, yay. Thank you. Something is probably going to mess up horribly. Nothing is happening. Nice. Why is nothing happening? Why is nothing happening? Does this have to be under this? Probably not. I'm probably doing this for no reason, but that's fine. Ah, please. What? What is happening? No, I am actually trolling. What is that? What is that? Okay. Yep. Nice. Follow path. Thank you. Okay, and I probably am going to need to loop this. Okay, nice. The enemy move works. Enemy move actually works. So I don't know what's going on. What is occurring? What is happening? What the fudge is happening? Why does it move? Why does it move back? What? What is going on? Okay, why? So it moves forward. Hmm. What? Why does it do it immediately? Why does it do it immediately? Aha, so move, you fu- Okay, nice, nice. Okay, I guess I do have to look at I do have to do a while loop here. I do actually have to do a while loop. Pretty sure. Come on, bro. What is happening? I followed his tutorial here.
Hello, in this episode we're going to look at coroutines. So as you
I literally followed his tutorial. Maybe that's it, I guess? No, because it would have done it then. Why is it instant? That's not what I wanted. That's not what I wanted. It's instant, bro. What? Do I need to make this like 0.05? Like, I'm so confused. Why is it instant? Why is it instant? Why? Why? What? The fu- Okay. What?
Now, before we do that, we can say if the current move coroutine is not equal to null, then we can stop that coroutine by calling stop coroutine and passing in the current move coroutine.
What? Does it need to be a coroutine? Really? Wait. What? No, dude! What? No, dude! Wait, let me see if I can actually find that real quick. Okay. Oh my, I have it in use for videos. It's not in silly. I don't know what I'm thinking. Here it is.
What? No, dude!
It just escalates so quickly. Okay, okay. Um, uh, um, can I do this? Wait, what? Oh, wait, I can just... I'll just do this, bro. That's that's a little bit more appropriate. What? Insane. Wait, can I? Wait. Can I just do this? And this? Bruh. That's fine, I guess, actually. Bro, whoa, whoa. Okay, what did I do on the other project? Can I open it? No. No, I can't. I can't open it in just Visual Studio. Let me go find it. Let me find it, actually. Um, bruh, please. Can I actually click on things, please? Data? Tools, bug reporter, Unity Hub, resources. What? Doesn't it show where this is? Assets. Show in Explorer. Unity projects. Documents. Why is it in documents? Okay. Weird. Coroutine learning. Is this it? Or was it follow? I think this was it. Current coroutine equals null. Okay. Huh. I don't think that's gonna help me, actually. Yeah, I don't think that's gonna help me. Why is it happening instantly? Seriously, why is it happening instantly? Why? Why is it happening instantly? And it's in the start one as well. Bruh. Wait, why is this working for me? I actually have no clue. Oh, it crashed. Nice. Nice! My Unity just crashed. That is sick. That's sickaroni, bro. Okay, Alt F4 doesn't work. Why? I'm like so confused, bro. You suck. Like, this is it. This is the problem. This is the problem. If I get this done, then I can fudging just watch the tutorial and pretty much finish in like 15 minutes. Or like half an hour, bro. This is it. This is the problem of the century. Let's see, how many of these are there now? Why is it instant? Why is it instant? I followed this exactly, bro. Like, does it seriously have to be? Does it seriously have to be right here? Like, fudge, man. Like, seriously. What the actual fu- Okay, the answer is yes. It seriously has to be right there, right in the loop. Bro. Also, it stutters. Why does it stutter? Yippee, I can pass through the wall. Okay, that is fine. That's fine, bro. That's fine. That's fine. Okay, maybe that's not fine.
So let's save that. And now if we press play and stop that coroutine by calling stop coroutine and passing in the current move coroutine.
Great. Um, oh, yeah. I mean that's easy. That's fine. Okay. Sure. Why do they have all these other ones? Whatever. Okay, great. Sure. And we just do this one time. Nice. Perfect. That is so stupid, bro. His is smoother. His is definitely smoother, but like it actually rotates the enemies, but that's fine. Yeah, I mean, could I do that? Could I do that? I would just have to. Could I do that? Could I do that easily? Could I do that easily? I would just have to, yeah, I would have to do another one. Here, I would have to do while. What is this even? And then how would I make it equal? Like, there has to be something about the position. Uh, like, I would have to find the. Hmm. But I need to draw array. Wait. Oh, fudge. Did you guys not see that? Whoops. Whoops. Yeah, turns out. Wait, did you guys actually not see that? Yes. Do I need. I said, do I need to really put the yield return null here in the loop? And then I did. Wait, when did I switch this? I don't remember. Okay, and then I did, and then it worked, and then it did this. Wait, when the f I'm gonna have to go back and look. Whatever. It's here now. So this worked. Okay, I'll just play it. What the fu- Okay, now I have to get it to work again. Nice. Yay. I don't remember if I was switched at that point. Maybe it was funnier that way. Okay. Basically, yes, this had to go here, and then I added this here. I don't remember when I switched it. It doesn't matter. It doesn't matter. What? The fu- Cannot implicitly convert type unity.engine coroutine to system.collections.enumerator. What? It's an I enumerator, you What in the world does not equal null that it stops it? Oh, whoops. Yeah, did I do this? Got it. Perfect. Place. Sure. I mean, that should work, right? That should do it in a loop, right? Wow, I love that. What the fu- Okay. Yeah, I guess I have to do this just up here, right? I'll just copy it. Oh. Then I can just do this, actually. Perfect. Yippee, and now it should turn around. When it gets there. And now it should turn around when it gets there. You little piece. But yeah, I also... You know, this is good to have. So I'll just keep it, I guess. Don't care, thank you. What the fuck? Why? Let's just speed this up to like 10 because I'm impatient. What the fuck? What? Why? 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 E. 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 Okay. Uh. I think 3 is too long, actually. Um. Why can't? Why? Why is this not doing it? Uh-huh. Uh-huh. Wow, my internet is crapping itself, I guess. Hmm. All right, time to do the good old 90 test here. Wow, it's almost like it doesn't even work. It's almost like this isn't doing anything. Isn't that crazy? Uh, path. Yeah, sure. Okay. So why did it work there? Why? What? Why why did it work there? Do I actually have to do this? Do I actually have to put it here? Actually? Really? Okay, nice, nice. How did that make a difference? How did that make any difference? How did that make a difference? Because you can't have anything after this, but I do have something after this. I have this. I have this after it. Okay. Boom. And then okay, never mind. Because it does this and then the return kicks it out and then it does this and the and the return kicks it out. Okay. Never mind. It works. Nice. So now I can start making. Now I can start populating the area here with enemies. That's fine. Okay, and now I can just. Um, hmm. How do I do this in a clever way? Yeah, you know what? Sure. Enemy number. Yeah, why not? Sure. And then it's gonna be really clever, guys. It's gonna be really clever. Ha ha ha. Okay, how many do I want? And where do I want them to go? I can actually finish this tonight, I'm pretty sure. Oh, I could have just made this like node or something. That would have been significantly easier. Um, yeah, let's see. Where do I want to put one? I want to put one. Do I want to put one going under here? No. That's fine. I don't want to put one. I don't want to put, yeah, one on any of the sides except this one. So I know I'm gonna do one here. What? Oh, that's why I don't do that. That's that's why I don't do that. Yep, so now I do this here. Beautiful. And I could just put it here. Yep, then I can just do this. Duplicate. Move. And I can just really move these wherever I want. Pretty sure. Perfect. Yeah, that's fine. These are not where I think they are they? Just have to make sure that's actually... Why does it default set it to 10, actually? Why does it do that? Can I move forward? I swear the controls are unresponsive sometimes in this. That looks like it might fit, probably. Okay, nice, perfect. Actually, I don't need another one. That's fine. Great. Let's see if it actually works. Nice. Wow, it actually does work. Nice. Pretty good. I feel like 2 seconds might even be too long still. Yeah, I'm just gonna make that one. That's fine. Okay, I'm a little sick of this. So I'm gonna make this like 30 or something. Now I actually have to see if that intersects here. It doesn't. Nice. Alright, set that to 5. Pretty good. Wow. I actually did it! Jeez! Jeez, bro. Alright. Let's make another one over here. Actually, let's make it lower. That's fine. And then let's get to duplicating. Let's get to duplicating. No? Okay, that clips. That 100% clips. 100% clips. And that's 5, and that's 5. Seems like the default number is 5, but it's just not, yeah, it seems like the default number is 5. I just don't have it anywhere for some reason. Wow, I actually did this kind of on my own sort of. Okay, then we're gonna have a guy over here. Yep, and he's gonna be right here. Okay, bam. Yeah, the perspective is a little off, I have to say. If this is not exactly in the middle of this block, it's not really gonna work. Is this 10? No. 9.8? What? What? That's 9.5, that's 9.75? I guess that's fine. 9.75, nice. And it also has to be 9.75. It doesn't have to be, but you know, but I like pride myself. I pride myself on detail. Is 9.75 actually the middle of this? No, it's not. 10? No. What in the world? What the fudge is happening? Oh, because it's relative. Okay, that's why. That's why. It's because it's relative. Okay, so this is going to be some wonky garbo here. Yeah, this is gonna be wonk. It's fine. This is going to be in the middle, as in the middle as possible, as I possibly can. Here. Sure, why not? And then I'll delete that one, then I'll duplicate that one, then I'll just move it over here. And then I'll duplicate, move. Perfect. Perfect. Okay, so far we have 4. I guess I want to do 2 more. Yep, 2 more. 2 more it is. Yep, perfect. And these don't all have to be rotating the same way, actually, now that I think about it. But that's gonna rotate the... That's gonna rotate. Okay, just gonna do a temporary fix here. And this one is in the middle, so it's actually okay. So this one can be 90. And then, but they're all gonna go the same direction. Okay, so I'm gonna have to, let's see. That one's fine. That one is fine, I guess. No, you know what? I want that one to be opposite as well. So what I have to do here is I have to do this, then I have to, is there a reverse order button? No. Oh, there is! Wait, there is? Perfect. That is perfect, baby. What the fuck? I didn't. What? And components cannot be reordered. What the fudge do you mean by that? What do you even mean by that? That didn't work. This also didn't work. Yeah, this also didn't work. I want this to be here? No. I want this to be here? No. Uh, Control Y. Okay, Control Y. Oh? 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 No. Okay. What are there for 5, 6, 7? I mean, there's probably an easier way to do this. It doesn't matter. Perfect. That works. Nice. Okay. Cool. That one can go that way. That's fine. This one, I want going the opposite direction. Thankfully, it is. Thankfully, it doesn't have that many. These. Actually, e, e, e. I don't even need to. Yeah, I don't even need to do that. I can just reorder these. That's fine. So now it goes boom, boom, boom. It's just going to be facing there. It's just going to be facing there to begin with. That's fine. Now I want this one to swerve, go down. So I'm going to rotate this one. Yep, nice. Yep, perfect, perfect. Nothing. Never been better in my whole life. That's that's perfect. Okay, one more here, baby. Let's do a little roop-de-doop-de, roop-de-doop-de. Do I want it to be here? Yeah, yeah, you know what? I want this guy to go. I want this guy to go, what in the world? Okay. Yeah, I want this guy to go through here and then back around there like that. Perfect. The cheating in this game is going around the sides, I guess. Like that's how you the cheesing, sorry, cheesing, because it's technically not cheating, technically. That is 100% clipping. That is 100% going to clip. Okay, this guy is going to be a straight shooter where he has a point every single thing. And then he's going to go over here. And then he's going to look in the corner. Yep. And then he's going to go back to the start, which means I don't need another one. Okay, let's check the path here. And this looks like it's going to clip. It 100% is. That's fine. Perfect. 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 Now I just have to add everything else. Now I just have to add everything else, literally. Let's see. Are they clipping? Yes. But that's okay, I guess. Actually, are they clipping there? Or are they clipping here? Yep, they're clipping a little bit there. Yep. And they're basically in the exact same spot there. That's fine, I guess. You know, I'm not making this game for immersion, so it should be fine. So now what is Brody doing? What the fudge is Brody doing over here? Um, Something is going on. Oh, I see. So occasionally they're not going to, occasionally they're not going to. So this guy is just is clipping here. That's good enough, I guess. So this guy's clipping here, yep. And it's 3 here. Boo doo 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 doo. Okay, that's good enough. So now let's get to the tutorial. Nice. That's nice. Very nice.
Hello, over the next few episodes we're going to be working on a mini stealth game project. So in this game, you're just trying to get to the finish zone without being spotted by the guards.
Two
This is going to work in the
times.
same way as
2 times is fine.
the previous Falling Blocks project, where every now and again I'll describe what we're going to be implementing next, and then challenge you to pause the video and try and get it working on your own. Alright, so in a new Unity project, I'm going to start off by creating a ground plane. I'll just scale this up a bit, and I'm going to create a material for it. Just call this ground. I'll make that a nice dark grey, and just assign it. Alright, I'm also going to create a capsule object, which is going to act as our first guard. So I'll rename this to guard, and also going to create a new C# script, also called guard, and attach that to the guard object. Now, we're going to want to be able to define a path for the guard to patrol. So I'm going to create an empty game object called path, and this is going to hold a bunch of empty children, which will act as each of the waypoints in the path. So I'm just
What?
going to top view quickly, and then create empty child, which I'll call waypoint 1. And then if I duplicate that, I can drag it out, keep duplicating it to make a simple little path. It's a bit difficult to design the path though when we can't actually see the waypoints, but I don't want to give them an actual graphic, so instead what we'll do is use something called gizmos. And gizmos are just things like this little light icon here, and also the camera icon, just things that you can see while you're in the editor, but which won't actually appear in the final build of the game. So how we'll do this is we'll go into the guard script, and in here, create a public transform variable called the path holder. So if I just save that, that's going to just have the path object assigned to it. And then in a special method called onDrawGizmos, we can loop through all of the children in the path holder. So we do that with a for each loop. For each transform, call that waypoint in the path holder. We can say gizmos
That seems excessive.
dot draw, and I'll just draw a little sphere at the waypoint's position. So waypoint dot position with a radius of, just say, 0.3. Now if we save that and go into Unity, you can see these little waypoint gizmos show up. And as we add more waypoints and move these around, you can see that visualized here in the scene view. And if you want to be able to see them in the game, you can also toggle gizmos on, and now those are visible there. But once again, once you actually build the game, these will no longer be visible. Now, it would also be quite nice if we could join each of these spheres with a line. So above the loop, I'm going to create a vector 3 called start position, which I'll set equal to the position of the first waypoint in the path. So we can say pathholder.getChild, and we want the child with an index of 0, and we'll just get the position of that child. And then I'll write vector 3 previous position is initially equal to the start position. And inside the loop, we can then simply say gizmos.drawLine from the previous position to the current waypoint
What?
position, and then the previous position gets set to the current waypoint position. Alright, so now if we go to Unity, we can see these are each joined with lines. And if we want this to sort of operate as a loop with the final waypoint connecting back to the first waypoint, then we can, at the end of the loop, say gizmos.drawLine from the previous position to the starting position. Alright, so like that, we should now have a closed loop to the starting position. Alright, so like that, we should now have a closed loop. Alright, so now that we've got this nice little visualization, we want to get the guard actually moving along this path. So let's go back into the script, and I'm going to create a
Well, that's interesting that he doesn't actually have to put that in a start update. I guess. Or the start in the
start method. And in here, I want an array
in
of
the
all
start method.
the positions of the waypoints in the path. So I'll create a vector-free array called the waypoints, and in here, I want an array of all of the positions of the waypoints in the path. So I'll create a vector-free array called the waypoints, and set this equal to a new array of vector-threes, and the size of that should be the number of children that the pathholder object has. So we can get that with simply pathholder.childCount. We'll then want to loop through each index of our waypoints array. So for int I
Uh,
equals 0, I less than waypoints.length, I plus plus. We can now say
Yep. Yep.
waypoints with an index of I should be equal to the ith child of the pathholder. So pathholder.getChild with an index of I, and we want the position of that child. Alright, so now that we have an array of all the points in the path, it's time for the first challenge, which is to get the guard patrolling the path. There should be a variable to control his speed, and also one to control how long he waits at each waypoint before moving on to the next one. Note that the guard moves in a loop going back to the first waypoint when he reaches the end. Okay, so hopefully we're able to get it working. I'll now quickly go through my own implementation. So I'll start by creating a public float for the speed, so that's something like 5, and a public float for the wait time at each waypoint, maybe 0.3. Then I'm going to create a follow path coroutine, so IEnumerator follow path, taking in an array of vector threes called waypoints, and I'll start by making sure that the guard is positioned at the first waypoint, so just transform.position is equal to waypoints with an index of 0. I then want an integer to keep track of the index of the waypoint that we're currently moving towards, so int target waypoint index is equal to 1, since we're already at the first waypoint, so we'll now be moving towards the second one, and then a vector 3 for the actual position of the target waypoint, so that's equal to waypoints with an index of target waypoint index. And then we can start our loop. So we'll just loop forever. So while true, we're going to move the guard towards the target waypoint with transform.position is equal to vector3.move towards from our current position to the target waypoint. And the maximum distance we can move this frame is equal to speed multiplied by time dot delta time. All right. Now if we reach the target waypoint, so if transform.position is equal to target waypoint, then we're going to want to move on to the next waypoint. So we can say target waypoint index is equal to target waypoint index plus 1 mod waypoints.length. So remember.
What? What in the world? Target waypoint index. What?
The modulus operator means that when this value is equal to this value, it will go back to 0.
But what?
So we can now say that our target waypoint is equal to waypoints with an index of target waypoint index. And now that we've reached the waypoint, we'll want to pause for the wait time. So yield return new wait for seconds, passing in our wait time variable.
Target waypoint index, what? Equals waypoint 0, so that's the first one, and then public transform path holder. Yeah, this is like, this sucks, bro. I'm not gonna lie, this way sucks. This way sucks. Like, this is so much, this is like actually worse than what I made. It equals 1, and then target waypoint equals, okay, and then move towards the target waypoint. Alright, if the position equals the target waypoint, then it equals, what? So it just goes back and forth. It just goes back to 0 and then 1 and then 0 and then 1. Target waypoint equals So target waypoint equals waypoint. What? This is the same. That's the same
And then
thing as
outside of
up
this if
there.
statement, we'll just want to yield for one frame between each iteration of the while loop. So yield return null. Okay, we just need to start the
Did I do that? Did I even do that? No.
follow path coroutine now. So in the start method, let's say start coroutine, follow path, and pass in our.
We want to wait one frame. Why do we want to wait one frame? I mean, I did do it here. Sure. I mean, that's fine.
Waypoints array. Let's save this and give it a try. So if I press play, we can see we're now moving between each waypoint, and once we get to the last one, we loop to the first one. Path and pass in our waypoint.
What? How is that working even? How is that even working? Okay, so that sets it to 1. So that sets it to the first waypoint. And then the index equals 1. And then the waypoint equals waypoints of this. So that goes to the next one. Okay. While true, transform dot position equals, so move the transform towards the target waypoint. Okay. If the transform dot position equals target waypoint, then the target waypoint index equals, oh, wait a second. Oh, what? Waypoints dot length? Oh, so I see. I see. So the length of the waypoints, so uh-huh. So 0, so this is this is basically just saying the index equals um, yeah, it equals the current index plus 1. That's all this is saying. So he didn't even need to do that. And then it goes back to the beginning. Okay. Like once it's the maximum, it goes back to the beginning. So if it's 1, then that would be what? Two modulo 18. Or 2 modulo, how many are there? I don't remember. 2 modulo 1, 2, 3, 4, 5, 6. Okay. So 2 modulo 6 is 4. Is 2. What? Okay, and then this is 3. Okay, and then 6 is 0. 6 goes back to 0. Okay, okay. Got it. Okay, so this just makes that equal to 2, and then the next time it makes it equal to 3, and then the next time makes it equal to 4, 5, 6, and then once it gets to 6, it goes back to 0. Okay,
Let's save
fair
this
enough.
and give it a try. So if I press play, we can see we're now moving between each waypoint,
Alright,
and once we get to the last one, we loop
that's pretty, that's pretty clever,
to the first one.
for
Now,
sure.
one thing that's a bit irritating is that the guard has sort of sunk into the ground. So going back into the script, we want to make sure that the waypoints have the same height on the y-axis as the guard object. So once we've assigned to waypoints I, we can say waypoints I is equal to a new vector 3, and on the x-axis it can just stay the same, so waypoints I.x, but on the y-axis we'll set it equal to the guard's position on the y-axis. And of course the z-axis just stays the same as well, so waypoints I.z. Right. So if we save this and try it again now, we'll see that the guard stays, thankfully, above the ground. Okay, let's now give our guard a spotlight. So I'm going to create a new light object, choose the spotlight, and I'll parent that to the guard object, just reset the transform, and just move it down on the ground here. So I can't really see it at the moment, but if we increase the range and the intensity, you should be able to see it streaming out. And maybe make this a yellowish color. Something like that is nice. Alright, so having done that, we're actually already ready for the second challenge. After reaching each waypoint and waiting for however long, the guard should now...
Okay, I guess maybe I need to just... Maybe I need to change this then. Open. Yeah. I guess maybe I need to change this. I'll just make this 0, and then I'll just make this, I guess I'll just make this, I mean, it looks almost exactly the same, but I'm thinking maybe it has a gameplay difference. Sure, why not 0.2? Why not 0.25? What does that do? Negative 0.25. Beautiful. Now, do I need this to be so intense? Yeah, I'll just do 10. That's fine. Alright, fair. Fair enough.
rotate to face the next waypoint before moving off. Alright, so let me...
Where are these things? Flashlights. Here. Alright, they're still there.
Once again, quickly work through my own implementation. So I'll start with a public float for the turn speed, set this equal to 90, so that's 90 degrees per second, and then I'll create a new coroutine called turn to face, and so we'll take in a vector 3 for the look target.
What the fuck?
And I want to calculate the angle that the guard will need to have on the y-axis to be facing the look target. So we know that if we have a direction, we can use trigonometry to find the corresponding angle. So I'm going to create...
Okay. Sure. How do I do this? Actually. arc, tangent. Is there direction? Transform dot direction? Is that a thing that exists? No. Yes. Vector 3 dot direction. I'll just see how he does it.
A vector 3 called direction to look target, which is equal to look target minus our own position dot normalized. Then the target angle is going to be equal to 90. I want to calculate with a public float for the turn speed, set this equal to 90, so that's 90 to look target. And I want to calculate the angle that the guard will need to have on the y-axis to be facing the look target. So we know that if we have a direction, we can use trigonometry to find the corresponding angle. So I'm going to create a vector 3 called direction.
All right, circle. Let's say there's a circle. Circle here. Circle. All right, this is the unit circle, but also the middle is the position of my of the player. All right, the player is looking this way currently. Let's say, just for the sake of simplicity, let's just say the position of the path point, or the node, or whatever the fudge, the path point is over here. Great. So it would need to rotate 90 degrees. Player would need to rotate or the enemy would need to rotate 90 degrees to get to this. So how we calculate this is, so tangent is y over x. So x, this would be x, that would be y, right? We do a tan x comma, sorry, y comma x. Then it should give us the angle here. That should equal 90. Actually, that should equal, yeah, 90. That should equal 90. So, what do we do? Length. So we calculate this by, okay, I don't actually know how to do that.
To look target, which is equal to look target minus our own position dot normalized. Then the target angle is going to be equal, which is equal to look target minus our own position dot normalized. Then the target angle is going to be equal to 90 minus arctan 2 of direction to look target dot z, comma direction to look target dot x. That's in radians. We need to multiply by this conversion factor of radians to degrees.
What? There has to be an easier way to do this in-engine built in, right? Like, am I tripping, bro? Hmm. Sure. Uh, Direction to look target dot Z. Okay, sure.
Alright, now to make the guard rotate towards this target angle at a time, I'm going to need a loop. And for now, just make this loop forever. And in here, I'll create a float angle, which is equal to mathf.move towards angle, going from the current rotation on the y-axis, so transform.eulerangles.y, to the target angle, with a max delta this frame of turn speed multiplied by time dot delta time. Alright, and I'll set transform.eulerangles equal to vector3.up multiplied by the angle, and then want to yield for one frame between each iteration of the while loop, so simply yield return null.
Okay, this doesn't need to, so this can actually just be true. What? Oh, I see. Yeah, that makes sense.
Now, I'd like this while loop to stop running once the guard is facing the look target. So I'm going to be using a method in the mathf struct called delta angle, which tells us how many degrees apart two angles are. So I'll say while mathf.delta angle between the current Euler angle on the y-axis
Yeah, that's way too complicated. What the
and the target angle,
I don't want to do
while
this.
delta angle is
I don't
greater than
want
zero,
to put the effort in to do this.
so keep rotating towards the target angle.
Target angle. Sure. So this is the position of the look target. That's, is it that easy? Really? I guess. I guess. Turn speed 90?
Now, it's really dangerous actually to just use a value of 0 here, because due to small imprecisions, the Euler angles might never exactly reach the target angle. So it's better to use just some small value here, say 0.05, and that'll be a lot safer. Okay, now up in the follow path coroutine, after we finished waiting at the waypoint, we can start coroutine and turn to face the new target waypoint. Now I'd like to wait while the guard is rotating, so we can just tack on a yield return command here. Now right up at the top of the coroutine, I'd also like to make it so that the guard initially faces the target waypoint, so we can just say transform.look at target waypoint. Okay, so if I save this and not command here, now right up at the top of the coroutine, I'd also like to make it so that the guard initially faces the target waypoint, so we can just say transform.look at target waypoint.
Sure.
Okay, so if I save this and now go and run the game in Unity, hopefully this will work correctly, and it does seem to be working fine. I'm just going to turn the wait time down to 0 and just ratchet up the turn speed and move speed variables just to make sure that it doesn't break. And it seems to be working very reliably, so that's good. Okay, now the third challenge is to create the player controller. You should be able to move the player around using the reliable and just ratchet up the turn speed and move speed variables just to make sure that it doesn't break. And it seems to be working very reliably, so that's good. Okay, now the third challenge is to create the player controller. And it seems to be timed down to 0 and just ratchet up the turn speed, and it does seem to be working fine. I'm just going to
speed 90.
turn the wait time down to 0 and just ratchet up the turn speed and move speed variables just to make sure that it doesn't break. And it seems to be working very reliably, so that's good. Okay, now the third challenge is to create the player controller. You should be able to turn on the game, so you can just say transform.lookat. Target to coroutine. Okay, now up in the to use actually to just use a value of 0 here.
Sure.
Because due to small imprecisions, the Euler angles might never exactly reach the target angle. So it's better to use just some small value here. Finished. Now I'd like to put the top target waypoint.
And this vector 3 dot up times angle thing.
Okay, so if I save this and now go and run the game in Unity, hopefully this will work correctly and move movement. The controller should also make challenge is to create the player controller. You should be able to move the player around using the arrow keys, and the player should rotate to face the direction of movement. The controller should also make use of a rigid body for collision detection. Alright, I'll go over my implementation in the next episode. Until then, cheers.
Okay.
The future of your business is here.
I don't care.
With Wix,
I don't
you get advanced.
care.
Hello, I'd like to start this video by quickly fixing a mistake that I made in the last episode, which is that if at any point in the path the guard needs to make an anti-clockwise turn, you'll see that this won't actually work. So once we get to this point, the guard just simply won't rotate. Now, that is because in the guard script, in the turn to face coroutine, the while loop only runs if the delta angle is greater than some small value. But what I forgot is that if the turn is anti-clockwise, then the delta angle is actually going to be negative. So what we want to do is take the absolute value of the delta angle, in other words, just make it always be positive. So we just surround this in a call to mathf.abs for absolute, like so, and now that should work fine. So if I just run this to make sure, we should see that it now rotates anti-clockwise. Great, so with that done, we can move on to the challenge that I set at the end of the last video, which was getting the player controller working. Since we're not going to be dealing with the guard for a little while, I'm just going to go ahead and hide the guard in the path object, and just go ahead and create a cube object called player.
Why did he have to do what? Why did he have to do absolute value? Couldn't he have just done? Isn't there a what is it? Can he just couldn't he just have? Couldn't he have just done an or? I guess I did the or. What is it? Inputs.x does not equal 0. It doesn't matter. If I do absolute value is greater than 0, it's not going to make a difference. It doesn't make a single difference. That's fine.
And I'll reset the transform on that and just bring it up to 0.5 on the y-axis, so it's resting on the ground. And I'll create a C# script called player, and attach that to the player object, and then open up the player script. So in here, I want...
So I'm gonna have to find out what he does with the rigid body to actually make it work. Otherwise, I am a little bit out of luck. So I am gonna have to give this a rigid body here. Yeah, this is where I'm following the tutorial.
A public float to control the move speed, and I'll set that to about, say, 7. And then in the update method, I'm going to create a vector 3 called input direction, and set this equal to a new vector 3 with input.getAxis raw horizontal for the x-axis, 0 for the y-axis, and then input.getAxis raw vertical for the z-axis. And then also normalize this since it's a direction. All right, so let's now try using this to calculate our rotation. We've seen how to do this before using the...
normalize it so it's a direction. I don't get it, bro. It's never gonna be... It's never, ever going to be... Oh, I already did it. Never mind. I actually... Never mind. I'm wrong.
Set the float target angle, is equal to mathf.htan2 of input direction.x, input direction.z. And then multiplying this by the conversion factor of radians to degrees. All right, so if we just say transform.Euler angles is equal to vector3.up multiplied by the target angle, then we should be rotating around the y-axis based on the keyboard input. So if I try this out, then we should be rotating around the y-axis based on the keyboard input. So if I try this out, that seems to be the case. Let me just select the player so we can see the actual arrows, and that does seem to be working fine. So let's now try moving the player with transform.translate along the object's own forward direction multiplied by the move speed multiplied by time dot delta time.
Yes.
And relative to space.world. Now, as it stands, the object will always be moving forward, but we don't actually want it to move if there's no input. So what we can do is create a float called input magnitude. Always be moving forward, but we don't actually want it to move if there's no input this time, and relative to space.world. Now, as it stands, the object will always be moving forward, but we don't actually want it to move if there's no input. So
What? What? Uh-huh.
So what we can do is create a float called input magnitude.
Oh, I see what he did. I see what he did. I see what he did. So he just, yeah, this just always moves the player. So yeah, this always moves the player, and this just controls the angle. Okay.
And just set that equal to input direction
I feel
dot
like
magnitude.
mine is
So
better.
that's essentially the length of this input direction vector. So it will be 1 if any of the arrow keys are held down, and 0 otherwise. So if we multiply this over here by the input magnitude, then if there's no input, it won't move. So let's
It just seems excessive. That's basically what I did here. What?
save this and try it out. So press play, and we can now move around. So that's very nice, but I would like to smooth things out a bit so that the turning and the moving isn't so abrupt. So let's go back into the script, and I'm going to start by getting a smoothed version of the input magnitude. So I'll create a float, smooth input magnitude, and then we want a public float called the smooth move time, so I'll set that equal to about 0.1. So that's sort of roughly the amount of time it will take for the smooth input magnitude to catch up with this target input magnitude. Then the smooth temp method that we're going to be using will need to keep track of the velocity of the smoothing. So we need to create a float called something like smooth move velocity for it to store that value in. And we can then say smooth input magnitude is equal to mathf.smoothtemp from the current value, so that's the smooth input magnitude, to the target value, which is just the input magnitude, and then it wants a reference to the current smoothing velocity. And so we use the ref keyword so we can actually modify the value in that variable. And we pass in smooth move velocity, and then the smooth time, which is just our smooth magnitude, to the target value, which is just the input magnitude, and then it wants a reference to the current smoothing velocity. And so we use the ref keyword so we can actually modify the value in that variable. And we pass in smooth move velocity, and then the smooth time, which is just our smooth move time. All right, so if we then multiply our move amount here by smooth input magnitude instead of just input magnitude, then if I now play this, we should see that as I move up, there is some smoothing applied. Now, one weird thing that's happening is that when I let go of the keys, the character starts moving upwards, because as soon as I let go of the keys, the angle is being reset to 0. So let's actually apply some smoothing to the angle as well, and we'll fix that problem. So I'm going to create a public float called turn speed.
Math f dot smooth damp? What the f... What the f... What is that, bro? What the fudge is that? Crap. What is that? What in the world? Why can't I... Does this not exist anymore? Math f dot... Okay, why is it not working? Does it... What? Oh, yeah. Yes. Dot smooth damp? What? What does this do? I'm not gonna worry about it. He didn't explain that
Set
at
that
all.
equal to about 8. And then we're going to keep track of the current angle in a variable over here. And we'll then say angle is equal to, I'm going to use the mathf lerp angle method to lerp from the current angle to the target angle with a speed of time to delta time multiplied by turn speed. All right, so then we just multiply by the angle instead of the target angle. And if we save this, we should see that there's some smoothing applied to the rotation now, but we've still got this problem that when I let go of the keys, it resets the angle to 0. So what we can do is tell it to stop interpolating the angle when the input magnitude is 0. So the simplest way to do that would just be to set the speed here to 0 when the input magnitude is 0, which we can of course do by just multiplying by the input magnitude. So if we do that and save and play, this should now be working how we want it to. Alright, now of course currently there isn't any collision detection being applied, so if we create some sort of obstacle, I'll just make a big cube here, like so, and we'll make a new material for obstacles. I'll apply that there, and maybe make that a red color. So if we now move into this obstacle, we just go straight through it. So to fix this, let's go into the player.
Yeah, he did not explain any of these things, bro. He did not.
And add a rigid body component. We'll then of course want to reference that component in our player script. So let's create a rigid body variable here called simply rigid body, I guess. And then in the start method, we can say rigid body, that should be with a small r because it's the name of our variable, is equal to get component of type rigid body. Now we'll be using this rigid body to set the player's rotation and position, so we can actually get rid of these two lines. And remember that rigid bodies need to be updated in the fixed update method, so we'll create void fixed update. And in here we can set our rigid body's rotation, this with rigid body.move rotation, and now I want to say quaternion for the new rotation of the rigid body. So we can say quaternion.euler, which is a method that converts a Euler angle to a quaternion. So our Euler angle is of course just vector3.up multiplied by angle. And then we want to set our rigid body's position. So to do that, we're going to need to know the current velocity of the player. So let's go up here and create a vector3 velocity. And at the end of the update method, we can set velocity equal to transform.forward sets the direction multiplied by move speed multiplied by the smooth input magnitude. So then we say rigid body.move position, and the new position is equal to the old position, so rigid body.position, plus the velocity multiplied by time.delta time.
What the fuck? What the fudge? What the fuck? I just spent so much time doing this. And that's not actually how you do it. It's not actually how you do it. You have to move the rigid body.
Alright, so if we save this and press play, we can still move around as before, only now you can see that we're actually constraining to collisions. Alright, so with the player mostly done, I'm going to shift him out of the way quickly and re-enable the guard, and I want to mess around a bit with the spotlight settings. So first of all, I don't want the spotlight to be sort of whited out by the directional light that we have, so I'm just going to turn down the intensity of that a bit. Alright, so the main thing that we can see is this spotlight, and I'm going to bring it up a little bit on the y-axis, so it's a little bit brighter. Turn down the intensity of that a bit. Alright, so the main thing that we can see is this spotlight, and I'm going to bring it up a little bit on the y-axis, so it's a little bit brighter, and also, need to change the shadow type to hard shadows so that the obstacle actually occludes the light. If we rotate the guard, we can see that working fairly nicely. It's not super accurate at the moment, but if we turn the bias value down over here, then you can see it's a little bit more accurate. I'm also going to reduce the range to about 13, but one thing we have to be wary of is that the range is 13, but once you actually get 13 units out, the light is very faint, so a player playing the game might sort of misjudge how far the guard can see, which would be a little bit irritating. So we're not going to use this range value as the actual distance that the guard is able to see. We'll use a slightly smaller value, but we can use this spot angle here for the guard's view angle. So let's go into the guard script, and we get a reference value for units super occludes on the y-axis, and I want to mess around straining to collisions. Alright, so and rotation plus the velocity multiplied by time.delta time. Alright, so if we save this, and position plus the velocity multiplied by time dot delta time.
What? Alright, I'm gonna do this tomorrow. I'm gonna do this tomorrow. That's fine. That's fine. Actually, am I gonna do it tomorrow? Yes. I just may do it very late. Alright. That's it for this episode. That should be episode 12, if my memory is not shot. And you will all see me tomorrow.